Hello and welcome to BioRules video lessons. Today I'm going to be talking about a very important phenomenon in different areas in science. But it's very important in biology and it's very important for cells, which is the surface area and the volume of bodies. So if we imagine the surface area and volume of a cell, in this case here, represented by a 1 millimeter cube. It could be 1 millimeter, could be 1 micrometer, could be 1 nanometer. It could be one whatever cube, as soon as you keep the same unit for all your calculations. So for a 1 millimeter cube, how do you calculate the surface area? How do you calculate the volume? Let's remind you of this. So surface area of a cube is quite simple. A cube is made of 6 squares, in its sides. So what you have here is the surface area of a square with side times 6, because there are 6 squares. So in this case here is going to be 1 millimeter times 1 millimeter times 6, which equals 1 millimeter square times 6, which equals 6 square millimeters or millimeter squares. This is the surface area of a 1 millimeter side cube. What about the volume? Well, the volume is easier. It's 1 side times 1 side times 1 side. They are equal sides. So in this case here is going to be 1 millimeter times 1 millimeter times 1 millimeter, which equals 1 cubic millimeter. And what's the relationship between area and volume? Although we cannot compare square millimeter to cubic millimeter because they are apples and bananas, I'm not dividing, I'm just saying how many units we have of one, how many units we have of the other. So in this case here we're going to have a relationship that is 6 to 1. I have 6 units of area to 1 unit of volume. Having said that, and you having reminded yourself of how to calculate area and volume of cubes, so now let's try to see how this surface area and volume ratio plays with different sized bodies. So, first question for you. Do you think this relationship of 6 to 1 is going to change when we increase the size of a body? For example, in this case here, we increase the size of the cube. So pause the video for a moment and try to think, is it going to change? If yes, is this relationship going to become bigger area to volume or a smaller area to the volume, or is it going to stay the same? So how is this relationship going to vary, if it varies, depending on the size of the body? Pause the video and then you come back after you have thought. Okay, now that you unpaused your video, we'll see here you have 3 cubes, 1 millimeter, 2 millimeters, 3 millimeter size, and instead of discussing, let's try to see what happens to the surface area and to the volume. The 1 millimeter size we have already calculated 6 to 1. So what will be the surface area and the volume for a 2 millimeter side? So 2 millimeter side is going to be area 2 times 2 times 6, which equals 24 square millimeters. Volume is going to be 2 times 2 times 2, which equals 8 cubic millimeters. And if you do the ratio between them, this is going to be 24 to 8. If you divide both sides by 8, you're going to simplify this to 3 to 1. Ooh, look, it changed. The surface area to volume ratio changes depending on the size of the cube. But I don't know if you said that it would increase or if it would decrease. In this case here, the surface area to the volume ratio decreases. You have less area to the same amount of volume, which is quite counterintuitive. Is this going to keep happening? Let's see the same for the 3 millimeter side. Surface area 3 times 3 times 6, which equals 54. And the volume, which equals 3 times 3 times 3, which equals 27. So the ratio is going to be 54 to 27, which equals 2 to 1. So you have a relationship of 2 units of area to 1 unit of volume. So this here might be counterintuitive, but this here is a classic relationship. Bodies, the bigger they are, the smaller is the relationship between the area and the volume. And the smaller the bodies are, bigger is the relationship between the area and the volume. So we say that the surface area to volume ratio here is reducing. It's getting smaller and smaller when the body gets bigger and bigger. Okay? Let's try to understand why. Okay, mathematically, if you like maths, we can put both volume and area when increase the size of a cube, in a graph. So here, surface area, I just plotted it. So this is how change for one side, two sides, three sides, six sides. So this is how the surface area changes when you increase the size of a cube. And what about the volume? The volume also changes, both of them exponentially. So the volume also increases. So we have for one side, two side, three side, eight side. So we have here the volume also growing. The difference is that the area grows to the power of 2. So grows in a square exponential growth, while the volume grows to the power of 3, so it grows to a cubic exponential growth. So both are going to be growing, but the volume grows faster than the area when a body increases its size. Okay? If you are not very fond of maths, if maths is not your thing, let's try to see this here in a different approach. Let's try to get a cube, okay, like this here, and I'll show you the sides. This cube here has 1, 2, 3 visible sides here, but also has one in the back, one on the top, one on the left sides. This has 6 sides. So if I get this cube with these visible sides that are in blue, and if I cut it with a knife, I will keep the volume. The volume is the same between both of them. We had a certain volume of this blue cube, and now we're going to have a certain volume of 2/2 blue cube. The volume doesn't change. But what will happen to the area? When we cut, some of the volume, or some of the areas stay the same. So we have the blue areas are the same, but we have 2 new areas here. We have 2 new surface areas that have just been created when I cut. So the volume is the same, but I have just increased the area. So when I have smaller and smaller and smaller pieces, I will have a relationship that's going to be bigger area to smaller volume. And when I have bigger volumes, bigger bodies, I have then a smaller area in relation to the volume. Let's try to see this again. Now I will cut this 3 times, and instead of 1 cube, I'm going to be making 8 cubes. So there I have, the blue ones are the old areas, and the red ones are the new areas created. So together I have the same volume, 8 pieces of cubes here make 1 big cube, the same volume, but now I have much more area. I have these red new areas over there. So whatever way that you find to understand this relationship, it's important that you understand that the surface area to volume ratio, when you have a cell or any body that grows, both the area and the volume will grow, but the volume is going to be growing faster than the surface area. The volume grows to the power of 3, the surface area grows to the power of 2. So a growing cell will end up having a way too big volume for its surface area. This is the relationship that we have here. The question is, so what? Okay, one very important thing is for you to understand this relationship. You should be able to understand and explain the relationship between size of bodies, surface area and volume, and the ratio between surface area and volume. But now let's talk about so what. What's the implication of this for cells? What the surface area and the volume are going to be representing in the cell's life. So we have a cell over here, and yes, you probably realize that that's the cell surface. The cell surface is represented by the membrane of a cell. That's the surface area of a cell, is the total amount of membrane that it has. What about the volume? The volume is related to the inside there, which is going to be related to the cytoplasm. Okay, so now you know what the surface area in a cell is, you know what the volume is, and the question comes again, so what? So what that the membrane controls what goes in and out of the cell. Cells are capable of getting stuff through the membrane, putting production and waste out through the membrane. So the membranes are absolutely necessary for the cells to do what they have to do. What about the volume? The volume is where they have things done, is where the chemical reactions happen. And the more volume you have, more chemical reactions you can happen. You can make, you're going to have there. So what is the implication then? The bigger the cell, more reactions it will make, or it can make, more material it has inside to do chemical reactions. But if you have more products to export because you're having more cytoplasm, if you have more raw material to import, you may end up with an issue, because you may end up with a too small area in order to be able to import enough material to inside of the cell. So cells, if they start becoming too big, they have a surface area to volume ratio that's not favorable. They end up with a too big volume for not enough surface area, and they will tend to die. So cells, usually when they grow, they have a rule. They divide or they die. Actually, there's a third possibility, that is that they stop. They stop doing what they're supposed to be doing. But most of them cannot stop. Most of them, they have to do stuff. So if they grow, they can't do what they're supposed to do anymore. So they end up dividing and making two half cells, which are smaller, and then have a favorable surface area to volume ratio, or they die. This relationship is going to be important in biology. For example, in penguins, a bigger penguin, this is the emperor penguin over here, the biggest penguin you have nowadays. The bigger the penguin, the smaller is the relationship between area and volume. So if it has less area, it means that these penguins, the big ones, they supposedly lose heat with more difficulty, because they lose heat through the area. So that means that a tiny little penguin cannot live in the place where the emperor penguin lives, in the interior of Antarctica, because it's too cold. Because they simply will have a too big surface area to the volume ratio, so that means that they will lose heat way too easy. That's one explanation there. Another relationship that will be important for us is surface area in our body. For example, when you have tiny little alveoli, you are going to be having lots of little sacs with a certain volume and, more importantly, with a certain area. And the smaller the little sacs, bigger the surface area to volume ratio. So in a lung, an adult lung has something between 4 and 6 liters. It may have a surface area that's bigger than a tennis field court. So because we have many tiny little small bags. The same goes for the intestine, the same goes for many relationships in the body. Bigger bodies don't have a favorable relationship of surface area to volume ratio. They end up having with a too big volume to its area. Okay, I hope you have enjoyed it, and we are going to be talking more about this in class. See you in next one.